Hello there, everyone. Thank you so much for joining us on today's webinar, Ensuring High Security in Your Cloud-First Strategy. As the title suggests, today we'll be learning about security, leveraging Google Cloud and all of its features. Next slide, please. Before we start with the webinar, please ensure that you mute yourself, that you do not share the screen, that you do not record the webinar, and finally, please put all of your questions into the chat to the right of your screen. Next slide, please. Let's begin with a brief introduction about Searce. We are a niche cloud engineering business that is born in the cloud. In fact, we have been a technology-led business transformation company for the last 16 years. Driven by the idea of driving technology-led digital transformation, we are now one of the top cloud and analytics solution and engineering companies in the Asia Pacific, Europe, and the United States. We work with organizations across multiple geographies and specialize in infrastructure and application modernization, data management, and finally, artificial intelligence and machine learning. Finally, our partnership with Google Cloud. Searce has actually been a Google Cloud partner for the last 10 years. We are a premier partner with Google Cloud and worked hand in hand with Google on various projects, boasting Partner of the Year for 4 years in a row. Next slide, please. As aforementioned, Searce has a footprint in 14 locations across the globe, with over 3,000 customers and over 300 engineers, boasting over 150 professional and associate Google Cloud certifications. We cover all of the major verticals and provide highly tailored solutions based on the client's use case or problem area. Next slide, please. Now a little bit about today's hosts. Michael Lucas is a solutions architect with Searce who specializes in Kubernetes and cloud security. Michael handles all of the deliveries for our North American region. Kristin Brotherton is a customer engineer at Google with a passion for security and infrastructure. She has 10 years of experience with infrastructure and 5 years of experience in the cloud. Next slide. Today, we will abide by the following agenda. We will kick off today's webinar with an overview of Google Cloud Security and the latest updates. Then we will discuss the specific security features in GCP. Then we will discuss the regulations and the associated industries. Then we will discuss the Google Cloud partner ecosystem. And finally, we will conclude today's presentation with time for questions and answers. So without further ado, let's go to the next slide. And Kristin, the floor is yours.
Awesome. Thank you. Next slide. Everybody believes in security at Google, from the software engineers to the facility teams that print out our tailgater security signs that hang on all the walls. When it comes to security on GCP, we like to break it up into 3 segments: protection, control, and compliance. First, we work hard to give you a secure foundation. Our core infrastructure is designed, built, and operated with security in mind. Second, we provide you, the user, with control and visibility. We understand how important security is for our customers and are constantly expanding our array of controls to help you meet policy, regulatory, and business objectives. Lastly, we work hard to make compliance easier. We invest a substantial amount of time to raise the security bar, not only for ourselves, but for our customers and the industry. With that being said, let's take a peek at some of our upcoming and popular products. Next slide. When we were chatting about topics to bring up during the webinar, one of the key asks was for some more info about confidential computing. Confidential VMs are a breakthrough technology that allow customers to encrypt their most sensitive data in the cloud while it's still being processed. It allows users to collaborate with anyone while preserving the confidentiality of the data. Confidential VMs and GKE nodes are both currently in preview, while VMs are slated to go GA first over the next couple of weeks. Next, we have another big announcement from this year's Next, which is Bigquery Omni. We have a number of customers who run in a multi-cloud configuration. Bigquery Omni is a flexible, multi-cloud analytics solution that lets customers cost-effectively access and securely analyze data across all three major cloud providers without leaving the BQ interface. Using standard SQL and the same BQ APIs, customers are able to break down data silos and gain critical business insights from a single pane of glass. Next, we have assured workloads. We hear a lot about compliance, and that message has been well received. We recently announced assured workloads for government to help address configuration and management of those heavily regulated workloads. I don't have too many details on what the scope of the product covers, but they should be releasing more information over the next couple of weeks. When I first started at Google from day one 6 years ago, I was fully equipped to work from anywhere in the world. The first thing that stood out to me the most was I didn't have to connect to a slow VPN to work remotely, which for me doing sysadmin work and being on call was a game changer. Google just recently shared this product with its customers. BeyondCorp is a zero-trust security model that shifts access controls from network perimeter to individual users and devices. It allows both employees and contractors to work more securely from virtually any location without the need of a traditional VPN. Lastly, one of the big announcements across all the verticals at Next this year was the customer-to-community platform, better known as C2C. C2C was created to build an independent community where our customers can learn, connect, and share knowledge. They have open pre-registration, so if you're interested in joining, please visit c2cglobal.com. I'm going to hand it back to Michael to give you a deeper look at the current products and best practices for securing your GCP environment.
All right. Thanks, team. So as Morris, our announcer, mentioned earlier, my name is Mike Lucas. I'm the solutions architect here at Searce, and I'm going to be taking you through some of the really powerful and useful features in GCP, at least the ones that pertain to security. So a little bit about what we're going to talk about. Firstly, we're going to talk about Security Command Center, which is really the hub of all these tools. There's multiple tiers of this, but the first tier is available for free. Anybody who has a GCP account can start using Command Center. Next, we'll talk about Secrets Manager and secrets management in general and some best practices in the cloud. We'll talk about Chronicle Anomaly Protection, which is a ML tool. We'll also talk about Cloud Data Loss Prevention, Access Transparency, and Access Approval, which is a really great tool and brings cloud logging and auditing to the next level. And then finally, we talk a little bit about AppArmor for DDoS protection. So firstly, Security Command Center. So you would think of Security Command Center as a central hub to organize, enable, manage, and visualize all of your security-related data inside of GCP. Command Center operates at the organizational level. So within Command Center, you enable it for your organization, and it gathers data about all of your projects within the organization and allows you to centrally visualize them. So a couple of the services that you can get from Security Command Center, of course, not limited to, Security Health Analytics. So you can use Security Health Analytics to visualize misconfigurations in VMs, GCS, IAM, and others as well. So this is, you know, the purpose of Security Health Analytics is to run heuristics and best practices checks against your resources, but functionally it does it in a way that can discover all kinds of misconfigurations and anomalies. It's a really powerful tool, comes standard with Security Command Center. Next, you have the Web Security Scanner. So the Web Security Scanner takes vulnerability management and penetration testing to the next level by automatically detecting any of your externally available endpoints and running vulnerability testing against those endpoints, and then visualizing all of the vulnerabilities in a single pane of glass. This is a very powerful tool, and to be frank, you know, vulnerability management is something that a lot of our customers have struggled with in the past, not specific to GCP, but everywhere. There are a lot of great tools out there, but using Web Security Scanner through Security Command Center is a great way for you to have a holistic and highly integrated approach to vulnerability management in the cloud, especially in GCP. So we also have event threat detection. So event threat detection is a feature you can enable in Security Command Center that uses live data from your security log streams, as well as VM agents to detect things like brute force SSH connections, IAM abuse, data exfiltration, and more. Event threat detection has your heuristics-based scanning to look for certain things that can happen, but it also allows you to discover anomalies. Event detection is something that, again, a lot of people struggle with because it's a very complex thing to solve. So some of you may have heard the term advanced persistent threat before. So the idea of advanced persistent threat is that there is an actor in your infrastructure doing things. And it's, it can be very difficult to track this type of activity across all the multiple APIs and log sources. And so some customers use external security incident and event management systems to aggregate this data. Event threat detection is tailored to GCP to make this experience easy and fast and accurate for your security teams to be able to discover these types of events. So next, there's container threat detection. So if any of you have used containers in the past, I know this is I would say this is a major focus of my career is containerization. Containers come with their own set of challenges. When you think about what a container is, it's essentially an image. So when this image is compiled and deployed, how are you sure that your image is secure? It's very difficult to ensure that. So there are tools out there to do, layer-based scanning and things like that, particularly that you can build into your CI/CD pipeline. But what container threat detection does, which is really unique and interesting, is it integrates directly with the container services in GCP and allows you to have essentially a central oversight of all the containers running your environment. Container threat detection can then do layer-based scanning and also activity scanning within these containers, just using its integration with things like GKE to discover security events such as SSH tunneling, rootkit activity, and binaries that were not originally packaged with your container. This is a really powerful feature, and to have this available in GCP through the click of a button, I was very impressed. So there's also a whole bunch of integrated services, and we won't cover all of them, but within Security Command Center, you can actually integrate with a lot of your third-party security tools, and as well as some GCP services, like Cloud Anomaly Detection, Cloud Armor, Data Loss Prevention, and others. So again, Security Command Center really is a centralization hub for all of your security efforts. So next, we'll talk a little bit about secrets management. So if you haven't heard of secrets management, it is exactly what it sounds like, managing your secrets. And a secret, well, what's a secret? A secret could be a database credential, an API key. It could be a configuration file. There's a lot of things that you could call a secret. And so Secrets Manager within GCP is designed to use any type of value and deliver it where it belongs through either the use of environment variables or others. So with secrets management as a practice, there is this first step, okay? And in secrets management, this is called the secure introduction phase. So secure introduction is that first password. You want, you want a container. Let's say this is a container. You want a container to be able to pull secrets. In order for it to authenticate to Secrets Manager, it needs to have credentials itself. And so, what's the difference between having an initial credential on that container versus just keeping the secrets there? So this is where a Secrets Manager, particularly GCP's Secrets Manager, really shines, because GCP Secrets Manager can use the concept of service accounts and the identity and access management platform within GCP to authenticate resources in your environment based on their assigned policy. So there's no initial credential. You're essentially using GCP's service accounts concept to authenticate to secrets. Secrets Manager is fully integrated with identity and access management. So You can control which secrets are available from which service accounts, which are able to write, which are able to read, etc. There are secrets manager tools available out there. Some examples of this would be HashiCorp Vault and a few others. But one of the great advantages of Secrets Manager is that it's fully managed. So this is a product as a service, essentially, within GCP that you can spin up very easily. There's no infrastructure set up for this, and it's hardened by Google. And they've informed, or this Google hardening process is informed by their vast experience in the security field. So again, another great advantage to Secrets Manager is that it offers parameterized delivery of secrets. So let's think about it like this. We have a VM image or a container, either way. Let's use the example of a container. You have a container. This container image, ideally, and this is just best practice, this container image would be deployed the same image to multiple environments, because that image is your artifact. You would configure the image to take parameters. These parameters would be, based on environment. So let's say this image is running in development. You'd want that container to take the development secrets so that it knows which database to connect to in the development environment, what user to use, what password to use. But then those secrets can be passed in the same way to the container, but through external mechanisms. So you're passing these things into the container through environment variables in GKE, for example. And doing this allows that container image to have the same credentials, rather the same configuration and same image across the environment that it's in. So here's a quick example of how you might use Secrets Manager in a Python script running in App Engine. You would import the Secrets Manager client library and then authenticate to the secret through that. Google has made this process very simple, and that's important. Secrets management is highly valuable to have, but you don't want it to be this enormous undertaking to absorb. Google has gone to great lengths to make security best practices easy to implement. And so the Secrets Manager client library is an example of that. So next, we'll talk a little bit about cloud anomaly detection. So I announced this as, what was it? I used a different name for this. But so cloud anomaly detection is what this product is called now, is absorbed by Google. So cloud anomaly detection uses behavioral signals from outside your system and displays granular information about security anomalies. So anomalies, let's say you're a person looking at a graph. You can very easily detect what an anomaly looks like. In fact, the way that the human mind works, it's very easy to discover anomalies in any type of environment. You know what a speck of dust looks like on a mirror. You know what a toy looks like when it's out of place. But for computers to be able to think this way is actually a great undertaking. So enter left stage, right? Machine learning. So machine learning has helped in a lot of different industries. It's helped with retail and e-commerce, etc., and marketing. But there's actually been great strides in using machine learning for security as well. And cloud anomaly detection uses machine learning to discover these types of anomalies outside of your normal usage within your project, to discover all kinds of things. So the things that cloud anomaly detection can discover, potentially leaked credentials. Credentials discovery, I mean, you've seen this potentially in some of your projects, like with Get Secrets, for example. Get Secrets is an external library you can use to scan a repository for credentials before it's committed. Get Secrets just uses simple regex to discover types of credentials. But cloud anomaly detection uses machine learning to discover what a credential actually looks like in all of its various forms, and can help you to discover these credentials where regex may fail. So unusual activity, I know this is a very broad one, but it's one massive advantage to using machine learning and security. Discovering unusual activity like spikes in API utilization, could help you discover when someone is committing a programmatic attack on your GCP projects. Bitcoin mining. Long ago, it was discovered that Bitcoin mining on the cloud was no longer profitable because of the cost of the instances themselves, but it's actually a common attack now for companies to gain access to a cloud platform through a leaked credential and then spin up a whole bunch of infrastructure and then mine for Bitcoin, Litecoin, etc. on that infrastructure because they don't have to pay that bill. Of course, this is theft and definitely something that we should try to discover. So coin mining is something that cloud anomaly detection can discover. Possible data exfiltration. The first thing that you ask, or at least the first thing that your CTO, CFO, and CEO are going to ask you after an exploit is, what did they take? If someone breaks into your office, this is very easy to discover, what's missing, but data can be copied. So it's actually really difficult to discover what and even when data is leaked from your environment. Cloud anomaly detection will essentially analyze your regular traffic and to discover traffic outside of your project, either at the network level or the API level, that is anomalous. So port scans as well. So port scans, very obvious, scanning for open ports in your environment. Cloud anomaly detection can discover these types of scans and alert you to them. SSH and FTP brute force attacks, again, obvious. Someone's trying to SSH in your environment, they fail, 10,000 times before they succeed. That's fishy, right? So cloud anomaly detection would discover those types of things. And also services in your organization that are used for external phishing attacks. There are services in GCP that can be used to send emails, to send external API calls, to gather data from or coordinate for a distributed denial of service attack. And these types of traffics, these type of activities can be discovered. They're very difficult for a human to discover just analyzing logs. Using machine learning for that is a powerful feature of cloud anomaly detection. And as we mentioned earlier, this, as well as almost all the services that we're going to explain here, are all enabled and controlled and visualized through the Security Command Center. All right, so cloud data loss prevention. So DLP is not a new concept. The idea with DLP is discovering personally identifiable information or confidential information before it's distributed or logged, before it's sent to a database or sent in an email, or before it's even written to disk. Now, you may have some security compliance requirements that no PII be stored in a database, but are you checking to see whether or not your application server is temporarily or even long-term writing this data to a local log file before it's sent to the database? A lot of times, no. So cloud data loss prevention can be used to discover this type of data before it's written to logs, to disk, or to databases, or sent to external APIs, and cleanse it for you. Or GCP uses the term de-identify. So you see, as you can see in the diagram below, we have a few entries here. On the left is the identified information. This is, clear PII. And on the right is an example of what de-identified information would look like. You can configure Cloud DLP to remove all or portions of your PII so that you can still have some information that, or look it up in external records if you need. All right. And so next we'll talk about access transparency and access approval. Now, access transparency has been around for a little while in GCP. This is a service that if you are evaluating GCP, you would look for immediately, especially if you're security conscious at all. You want to make sure that there are real-time logs. You want to be able to track activity in your GCP console and APIs. So what Access Transparency does is it creates logs in near real time when GCP administrators interact with your data for support. So the idea here is not just at the Cloud Console level, but also other levels like BigQuery, for example. Who is running queries against specific types of data? Who is opening or auditing my IAM policies? These are things you would want to see, that you'd want to analyze, and that you would want to visualize. And maybe all this, activity is normal, but you want to be able to look at this data and have it put together in a digestible format so that your security teams can follow advanced persistent threats or bad actors, one, after the fact, but ideally before the fact. And speaking of before the fact, enter access approval. So access approval is an entirely new paradigm shift, I would say, in the idea of cloud logging and auditing, because access approval allows you to explicitly approve access to your data in line. So let's say a user is about to connect to an Access Transparency enabled service. They attempt to do this either through the console or the G-Cloud API or CLI, and they don't have approval, but it's eligible for access approval. Your administrator, and of course this is all configurable here, your administrators could receive an email that would ask them whether or not this user is allowed to access this resource. And then that administrator could either approve or deny this request. So in the past, traditionally this is handled through tickets. You go, your enterprise, your organization, you open up a ticket, your administrative or security team will then add you to whatever groups you need to be in order to access your data or your APIs that you need. But with access approval, you can do this type of approval in line and either on a permanent or temporary basis, which is honestly, it's just a powerful, very, very powerful tool. So the access approval is an additional layer of control on top of the transparency provided by Access Transparency logs. So, it's available in GCP and is available to anybody who would like to use it. So there are a couple services within GCP that Access Transparency and Access Approval support. So one is App Engine. This would be, access to App Engine APIs, access to change App Engine, etc. BigQuery and Bigtable for accessing data. Cloud Identity and Access Management. Of course, we want to know when someone is making changes to our IAM policies. Cloud KMS, Key Management System. Another very critical security service within GCP. You would want to know if someone changes permissions on your managed keys. Google Cloud Storage. Oftentimes, GCS, Google Cloud Storage, is used to store certain types of encrypted data, secrets, or even PII. And so understanding when that's accessed and potentially seeking administrator approval or secondary approval for access to certain types of data, powerful service. This can even be used for compute engine and persistent disk, as well as data flow and pub sub APIs. So lastly, within the security services, we'll talk about Cloud Armor. So Cloud Armor is a DDoS protection product that offers DDoS protection from layers 3 to 7. And it's the same, or at least similar technology to what Google is using to protect its SaaS products, which is, an amazing advantage to using GCP. Cloud Armor is meant to attach to an HTTP or HTTPS load balancer globally to detect and prevent incoming DDoS attempts, and has some really great tools for configuring how it needs to do that. So there are some language rules for deny and allow. You can set up these language rules to block entire CIDR blocks or entire geographies in the case that you have data that needs to only be accessed by certain geographies for data residency or compliance purposes. It's done in the same way that firewall rules are done, where you have a policy, you have a rule, and you have a target. So another cool advantage to Cloud Armor is that it has preview mode. Now, when you're thinking about setting rules at a web application firewall or a load balancer level, there's always a concern that regular traffic will be blocked by these rules. But with Cloud Armor, you can set the rules to preview mode, and it will log how many of those requests and what requests are being blocked by the rule that you've just implemented. So you can determine whether or not, based on regular traffic, that might compromise the functionality of your application or API. So next, we're going to talk about regulations. So there are many regulations out there, hundreds even. What I'm going to talk about here is some of the regulations that are commonly run into, and then some of the industries that those regulations apply to. And then we'll also talk about some of the features within GCP that we've talked about and otherwise that can be used to assist with ensuring compliance against these standards. So financial services, and while I was doing research for this deck, I discovered at least 30. Financial services has a ton of security compliance standards that must be met. I mean, there's a lot. I've mentioned 3 here, the TILA, Truth in Lending, PCI, and Federal Reserve. But there's so many others, like GDPR, for example, that offer true challenges for companies that are trying to achieve financial services standards compliance, not just for the public standards and that certification, but also for vendor management. If you're in financial services and you're working with a bank, this bank will generally send vendor security questionnaires. And these questionnaires will ask a lot of really probing questions. And in some cases, and I've seen this in person before, these vendors will send auditors. And so what these auditors are looking for is maturity. Now, a mature security practice is, it can be difficult to achieve. It's something that's built up over time. But with the services that are available to you through the Security Command Center and otherwise in GCP, security maturity is really just a matter of checking the box. Now, of course, that's an oversimplification a little bit, but you're accelerated, especially as a startup, you're accelerated in achieving some of this type of maturity that other companies have had to work for years for. So financial services, TILA, PCI, and Fed Reserve. One of the biggest things that I found that is lacking in reaching these types of compliances is penetration testing and vulnerability management. And there are so many tools available, but companies aren't doing it, and there's a lot of reasons why. But again, we talked about web application vulnerability management in Security Command Center, which is essentially just a checkbox that you enable, and those endpoints are automatically discovered. Having that kind of deep integration with your cloud makes the process of enabling and doing penetration testing in your environment a lot easier. And of course, I would say that any of the products that we've talked about today apply to any of these sectors, but I'm just giving some examples. Government and public sector. Now, of course, government has so many different standards to comply with. Some of those primarily being FedRAMP, FISMA, CMMC, which is a new thing that came out very recently, and then of course NIST, which has been around for a little while. So honestly, one of the biggest things that I saw with government and public sector is the protected VMs that Kristin was talking about earlier, confidential computing. That was one of the biggest challenges to government adopting cloud in the first place, is this idea of a shared hypervisor. So using confidential computing gives customers far more control over the physical hardware that's running in their environment. And this helps them to be more compliant with a lot of these standards, and also really just improve their stance altogether. So next is healthcare and life sciences. So HIPAA is obviously the thing that comes to mind right into the forefront here. HIPAA compliance is really about and solely focused on patient data and controlling where, how, and what is shared with external parties. And it's not just a matter of forms. I've heard some people say erroneously, sorry, that HIPAA is just a matter of signing a BAA and doing paperwork, but it's not. We need to ensure that as we're putting these things together, you know, as we're putting this infrastructure together, we're verifying that this data is not going where it shouldn't go. We're verifying that any data that is sent out or that leaves the perimeter has been sanitized. DLP comes to mind as a really powerful tool in this category because we want our data to be sanitized. We want to make sure that we're storing only what we need and that anything that's transferred is transferred and sent according to what we define within our HIPAA policies. So next is retail and e-commerce, and of course PCI comes to mind here. There are a lot of ways to bypass the need to process credit card data, essentially using external vendors and external processors. But invariably, if you're selling things online, there will be a portion of your infrastructure that has to be PCI compliant. I've seen this minimized even down to a single JavaScript file, but that's there. PCI is prevalent anywhere that there's credit card processing data, which applies to any of these essentially. And PCI is really about network segmentation. It's about making sure that your environment is segregated, not just at the network level, but also from an identity and access management level, the teams who are manipulating PCI environments, etc. VPC is useful here. IAM is useful here. And some of the machine learning capabilities that we've talked about earlier can be used here as well, because you could very easily discover or visualize when a user who has never done anything on a certain, or a particular project that's designated PCI suddenly starts doing things. That would be anomalous behavior, and showing that you can detect that helps to show the auditors that you're thinking about segmentation and that you're making sure that you are building your PCI environment according to their standards. So next is education. So education is a weird one. There are a few that are specific to education. FERPA, FISMA, and HIA. Education really encompasses the challenges that are in healthcare and retail combined. And so with this, you want to make sure that you're protecting your student data like PII. So DLP applies here, and anomaly detection applies here. Now, a lot of companies in education have public endpoints. They're using Blackboard or they're using some other tool that their students sign into on a regular basis. So, this external application needs to be secure because it could very easily be compromised. So, this is where the web application scanning and vulnerability management capabilities of Security Command Center can really shine. Okay, well, so that concludes the technical portion of what I wanted to talk about today, at least from a high level. I'm going to hand this back to my good friend Kristin to talk a little bit about the Google Cloud partner ecosystem and some of the things that Google is doing with their partners.
Awesome. Next slide. Oh, there we go.
I got excited.
Yeah, no worries. So Google provides security for 8 products with over 1 billion users each. We've worked really, really hard to bring that same level of security and trust over to our GCP products. Next slide. With that being said, security in the cloud does require collaboration. We rely heavily on partners like Searce to help guide our customers on best practices and solutions for securing compute resources. Here we have a graph, and it shows the different kind of handoff levels between each of our different product types. Our partners build on our products and develop innovative solutions, creating new opportunities for our customers and expand on what's possible in the cloud. They have a deep understanding of security handoff points and can help customers across multiple industries and achieve their security standards. As Michael mentioned, he has a deep understanding of the products that are applicable to each circumstance whenever it comes to specific regulations. And we rely heavily on them to kind of provide those security standards and handoff points. Think of them as just one more layer of security to kind of add into the equation.
Nope, I would just like to say thank you, everyone. Thank you, Michael and Kristin. This has been a very fruitful conversation.
Thank you for joining our webinar, and we hope to have conversations with you all in the future. Thank you.